So, we're today May 12th, and a few days ago I was successful in communicating via UART to the BMS of the boosted board V2. A few people have been asking how to do it. Disclaimer, as of today, connecting to UART to the BMS will not give you anything. You will not be able to unbrick it. You will not be able to remove the red light of death. It is only for testing purposes and for curiosity, really. What you will see is that you will see debug messages. You will see data like bootloader and firmware version, and potentially some information about the battery, how many charge cycle, how many write has happened to the flash memory. So first things first, you will have to go watch the video from Dr. Battery, and he shows how to pry open the battery and remove the battery module. And it took a lot of effort, a lot of prying. It was scary. So go watch that if you are courageous enough to break your battery. Be aware that like the moment you remove the battery module from the enclosure, it will lose its waterproofness. If you want to undergo this, you should probably not use your battery after that. Let's go through the things that you need. So after prying it open, you will need a computer along with a USB cable and a SparkFun FTDI connector. It could be any FTDI connector actually. So here's a close-up FTDI from SparkFun, that's what I'm using. And here you will disconnect the BMS. You will slowly lift this PCB. Side comment, in order to remove this connector, you will have to remove a lot of gunk here. I'll show the bottom of the PCB. So you see there are 5 pads here. 2 of them are labeled TX for transmit and RX for receive. These pads connects to the debug port at the top. So what you will do is you will solder a cable on the TX and another cable on the RX, and a third cable going to ground here. So now you have 3 cables coming out of your PCB. So I use a male-to-male header. So I soldered the ground cable, for me it was the white cable, to the ground pin, and the green cable is TX. TX in this case goes to TX, and the blue one is RX. RX goes to RX. So now I have this connector that goes to my FTDI device, and I connect my mini USB to the computer. I plug back the battery monitoring cable to the BMS. On my computer, I will be using RealTerm, but you can use like PuTTY or TerraTerm. Even the Arduino serial monitor works too. In RealTerm, I have it configured to read ASCII. In port, to the baud rate is 115,200. The parity is none. Data bit is 8. Stub bit is 1, and there's no hardware flow control. So now I can open the port, and I can turn on the battery. And as you can see, debug data is coming in. What you can do at this point is to also record the output and log it. The charge state, you see the bootloader version, the write counts, you see also boot count, the package manager, firmware version maybe, 2.17, and then there's a lot of other information which I haven't really understood yet. There's still a lot of like reverse engineering required to figure this out. But yeah, so that's how you connect to the BMS and how you fetch debug data from the battery. I tried transmitting stuff to it, but haven't found really anything that works. It looks like it might require some specific commands. So yeah, so that's where we are, and we are able to get debug data out. We were unable to send any data to it, and this will not, as of now, you will not be able to repair or reflash the firmware. So the more people try stuff on it, the more discoveries we'll have. So hopefully you can also try that at home if you have a dismantled boosted board battery, and hopefully one day we can figure out together how to unbrick our boosted board battery. So if you enjoyed what you saw today, feel free to hit that like button, and if you want to see more of it, then feel free to subscribe. Alright, I'll see you next time. Bye.